video, we will talk about hypothesis testing. In research, or I can say in applied science or science, we do research, experiment, survey, right? And when we do these survey or experiment or research, yeah, we make claims. We make claims, or I can say we make assumptions in applied science. Now, those assumptions or claims of the survey, experiment, research, or any kind of assumptions when we made. Now, those assumptions and claims are need to be validated or disprove. Obviously, we need to, we can validate those assumptions or disprove, right? So basically, in statistics provide us these kind of tools that we can validate the assumptions of any experiment, research, survey. So these tools are known as hypothesis testing, right? Basically, the hypothesis testing is the inferential method where we try to validate any assumptions or claim of any survey, experiment, or research, or any kind of assumptions, right? How do we validate the assumptions or claim with the help of hypothesis testing? Obviously, by supporting it or by rejecting it on the basis of evidence, right? On the basis of the evidence in a hypothesis testing, we validate the assumptions of any research, experiment, or survey, right? These evidence in a hypothesis testing is a probability. Yes, on the basis of the probability, we will support or reject any kind of assumptions, or I can say claim, right? So how do we basically do this? For example, and one more thing before I go ahead, these assumptions of experiment or survey or any assumptions are made on parameters, the population parameters. These parameter can be mean means average, or I can say these assumptions can be made on proportions, right? It is always be like that we make assumptions on parameters. There can be average, there can be proportion, and like that, right? So let's take the example. Suppose I want to make assumptions. I want to take example of experiment. We take experiment, right? Then experiments, we want to check any drugs, any specific drugs that are effective for headaches, I can say, or migraine disease. These drugs are effective for migraine disease. So experiment is done, and then they make assumptions. The drug A is more effective. Drug A is more effective than drug B for headache. So these are the assumption is made by the experiment, right? So when I say these assumptions are made on parameters, so here these are in the words. Assumption are in the words. How can I do this in a parameter? Here you can say the assumptions of experiment says average person cured by drug A is not equal to average person cured by drug B. Means another term, it is saying that drug A is more effective than drug B. Or in the parameters, I can say the average person cured by the drug A is not equal to the average person cured by drug B. So this is the experiment assumptions, which is stated in a hypothesis. When we do hypothesis testing, we do states the hypothesis. One is known as alternative, and second is known as the null hypothesis. The alternative hypothesis is the assumptions that made by experiment. The experiment made assumptions that every person cured by drug A is not effective, not equal to the average person cured by drug B. So when we make alternative hypothesis, which is also known as the HA, we also make null hypothesis. hypothesis. What is the null hypothesis? Null hypothesis will be say, if it is saying that drug A is not equal to drug B, the null hypothesis will be said drug A is equal to average person cured by drug A equal to average person cured by drug B. That is how we make that is how we start the null hypothesis testing, by stating the null hypothesis and alternative hypothesis, right? This is the experiment assumptions made on a parameter, on a average or mu, right? We stated this experiment assumption as the alternative hypothesis, and we made a null hypothesis thesis, which is saying that it is not equal. It is always be like that, right? The experiment made the assumption that there is a equal, that is not equal. The null hypothesis always be like that there is equal. It is always be like that, mostly in cases. So that is how we we states the null hypothesis and the alternative hypothesis, and there are other steps. After we state the null hypothesis and alternative hypothesis, there are other steps that we should follow. After we follow, in the end we will make a conclusion on a sample. Either we should reject it or support it. If it is supported, if the null hypothesis will be supported, it means that at the significance level we can say that drug A is equal to drug B. There's no difference between drug A and drug B. We can say this at the significance level. That is the terminology that we use in the hypothesis testing to do the validation of any experimental assumptions. We say with the significance level we can prove this. So when we support or reject the null hypothesis, we will be able to make decisions, right? So what are the steps that we should follow? These steps you can see there. As I say, the first step is stating the null hypothesis, which is say the average person cured by drug A is equal to the average person cured by drug B. The alternative hypothesis, which is the assumptions claim of the experiment, that said average person cured by drug A is not equal to the average person cured by B. Second step is the significance level. What is the significance level? Which is always be like 1%, 5%, or 10%. We always be set the threshold of the significance level, which is denoted by Greek letter alpha. It will always be like 1%, 5%, or 10%. Now, what are the significance level? Significance level basically says when we do the hypothesis testing, that what are the percentage that we make wrong decisions. When we are supporting or rejecting the null hypothesis, what are the percentage that we can make wrong decisions, or I can say the errors. So that's why we set the threshold of the percentage. This significance level is this threshold is set by the domain expertise, right? If we do the research or experiment, this significance level threshold is set by domain expertise. Now, one more thing, in a hypothesis testing is the inferential method, right? That in hypothesis testing we made on a sample, right? We take a sample, and based on sample we draw a conclusion about population with experiments, you can say the survey, research, any kind of thing. And as I said, we will support or reject the null hypothesis based on probability or evidence. This evidence is the p-value. P-value is basically probability, right? The probability of any score where need to be true, where we assume that null hypothesis is true. Basically, based on this probability, we will support or reject the null hypothesis. If the p-value is less than alpha, we reject the null hypothesis. Means the probability is probability in this distribution, right, is less than, it is present in this region. The p value of the score is present in this blue region. When we present in this blue, when the p value is present in the blue region, we reject the null hypothesis because it is very far from the null hypothesis, right? This is the threshold we make, which is known as alpha. That can be 0.05, means 5%, or 1%, or 10%, right? Another video I will explain in a detail what is the p value or and the significance level for these different topics. I will make separate videos. So these are the steps. We first state the null hypothesis. We set the significance level, because we are taking hypothesis always be done on a sample. We take samples. They can be 1,000, 100, whatever. We taking sample from the population, and we calculate the p value. After calculating the p value, if we see that the p value is less than alpha, we will reject the null hypothesis. If it is p is greater than alpha, we support, or I can say the fail to reject the null hypothesis. Right. These are the steps we follow to conclusion about. After this, we will be able to make a conclusion about experiment, assumptions of the experiment, that drug A is more effective or not. If the p value is less than, we will reject the null hypothesis, and we will be able to say yes, the drug A is more effective with the drug A is more effective than drug B, right? If the p value is greater than alpha, we fail to reject null hypothesis, right? Means the null hypothesis is supported. We support the null hypothesis, and we can say there is no difference between drug A and drug B. And that is how we do the hypothesis testing. That's all about this video. In the next video, I will discuss about the significance levels, and then I will discuss about the p value, right? And what are the types of the hypothesis testing, right? We will discuss this later.